Hi everybody! Today we're going to be doing the Physical and Chemical Changes lab. So make sure that you have your lab handout open on one screen and your video playing on another tab. Okay? There's going to be one edit to the video because nobody's invented smell-o-vision yet. So obviously you are not going to be able to record odor or smell. So in the data table you can either just ignore that column, or if you want to, you can go ahead and put X's or shade in the boxes, but we will not be collecting that data because you can't do it. So our objective today is going to be to observe the physical and chemical properties of various substances that I've got laid out on the lab bench, and also to classify our observed changes as physical changes or chemical changes. So as you can see, I've got everything set up for me here, and what I'm going to be doing is taking the camera and zooming in on various things as we go through the procedure. But I'm going to be following the procedure from the lab handout exactly as it is written, so you can follow along with me step by step. Okay? Let's get it. Okay, so I have zoomed in on our samples. I know in the procedure it says to use test tubes, but the camera wouldn't exactly focus on that, so I've instead put them into weigh boats so that you can record their physical state, solid, liquid, or gas, and their color. Right? So our first chemical is sulfur. So take a look. Our second chemical, as you can read, is iron. Our third chemical, sodium hydrogen carbonate. Number 4, sodium chloride. Number 5 is sucrose. Number 6, silicon dioxide. And number 7 is magnesium. So if you need to go back to see one of those, make sure that you do, but record the physical state of each chemical and its color. Okay, so now we're back into the test tubes, and we're going to be doing step number 4, testing for solubility. Solubility meaning dissolve or not dissolve. Okay. And I know that we said that we were skipping the odor, so step number 3, and that is true. Fortunately, you're not missing much. The only one that has an odor is chemical number 1, sulfur. Sulfur is actually added to propane so that propane has a smell. So if you think about what propane smells like, a little bit of rotten egg, that's the smell that sulfur has. Okay. Let's find out if sulfur dissolves in water. So I'm going to be using my pipette to add 5 milliliters of water to test tube number 1 with my sulfur. So. So maybe jot down some observations. What happens when I just add the water? So now I'll use my stirring rod and I will agitate it. So what is happening there? What do you think? Soluble or insoluble? Make sure you record your data. All right, let's take a look at number 2, iron. Now I wiped off my stirring rod so that I'm not cross-contaminating my chemicals, but let's see what happens when I agitate it and stir it up. What do you think? Soluble or insoluble? Record your data. Chemical number 3, sodium hydrogen carbonate. Let's agitate with my clean stirring rod. What do we think about sodium hydrogen carbonate? Record your data. Chemical number 4, sodium chloride. Agitate with my stirring rod. What do we think about sodium chloride? Make sure you record your data. Chemical number 5, sucrose. Stir with my clean stirring rod. What do we think about sucrose? Record your data. Chemical number 6, silicon dioxide. agitate. Make sure you record your data for silicon dioxide. And last but not least, chemical number 7, magnesium. Let me get my clean stirring rod and let's agitate. So make your observations and record your data for magnesium. Now, solubility is one of these tests that can be a little bit tricky because sometimes it takes a while for you to really be able to tell if something is going to dissolve or not. So before we move on to the next step, let's go back and look at all of our chemicals one more time just to be sure that we've got our data correctly recorded. So if we look at sulfur, does it still look and match what you originally recorded? If not, you can edit your data. How about iron? Number 3, sodium hydrogen carbonate. There's a bit of bubbles in the test tube here, so don't let that fool you, but sodium hydrogen carbonate match what you originally thought? Number 4, sodium chloride. Number 5, sucrose. Come back just a little bit, maybe we can get that in better focus. Number 6, silicon dioxide. And number 7, the magnesium. So double check your solubility data. Okay, at this point, I have done step 5 and step 6 of the procedure. So I disposed of our solubility tests into the waste container and I added a small sample of each of our chemicals onto weigh boats instead of pieces of paper, because it makes it a little bit easier for you to see on camera. So now, as you can see right here, we've got a bunch of magnets being held up into the beaker. And what I'm going to do is take the weigh boats with the chemicals and put them over top the magnets to test whether or not they have any effect on the chemical. So we'll start with chemical number 1, the sulfur. So are you seeing any effect of the magnets on the sulfur? Record your data. Chemical number 2, the iron. So are you seeing some effects of the magnets on the iron? Record your data. Chemical number 3, sodium hydrogen carbonate. Any effect of the magnet here. Record your data. Chemical number 4, the sodium chloride. It's a little hard to see. It's over here in the top corner. Any effect on the magnet? Out of focus. Chemical number 5, the sucrose. Magnets doing anything to sucrose? Chemical number 6, silicon dioxide. And finally, chemical number 7, magnesium. So record your data for how the magnet either did or did not affect each of your chemicals. Okay, so I have set up for steps 8, 9, and 10 in our procedure. So in our first test tube on the left, we've got magnesium. The next test tube, we have the sodium hydrogen carbonate. The third, we have sodium chloride. And the fourth, we have our silicon dioxide. So what I'm going to do is I'm going to add our 3.0 milliliters of hydrochloric acid to each of our test tubes. But I'm going to do it one at a time so that you can see any effect that the acid is going to have on the chemical. For these tests, you're going to want to make either a new column in the data table, or you can create a separate data table and title it acid tests. Up to you. So I'm going to take my hydrochloric acid and I'm going to add it to my magnesium. So let's watch what happens with acid and magnesium. What the what? The magnesium's totally gone. And if I feel the outside of my test tube, it's really hot. What kind of chemistry science magic is this? Let's find out what happens when I add my acid to the sodium hydrogen carbonate, the second test tube. Who said you had to go to Hogwarts to see magic and potions class? So you can hear it fizzling. When I feel the outside of this test tube though, it's really cold. You can kind of see there's some condensation there, but this one's really cold. Let's find out if anything cool happens with the sodium chloride in acid, the third test tube. So no sound effects. Doesn't appear to be having any temperature change. So record some observations for that. The sodium chloride with acid. Last but not least, let's test silicon dioxide with acid. So once again, no sound effects this time. No temperature change either. So record your data for the silicon dioxide with hydrochloric acid. The last step is to dispose of my waste, which I will take care of. So if you missed any steps or forgot to record any of your data, go ahead and go back in the video so that you can fill out the data table. Once again, for the acid tests that we just did, make sure you either add another column to the data table or, as you are prompted to do in the procedure, create your own data table for those acids tests. Your individual teachers will be talking to you about this lab. So go ahead and take a look at the analysis question so you are ready for the discussion. Bye guys!